Alright, we're on chapter 6, section 7. We're going to talk about the areas of squares, rectangles, parallelograms, triangles, trapezoids, kites, and rhombuses. Oh yeah. If you have your reference sheet, you might want to pull it out today. We haven't used the reference sheet in quite a while though. Your reference sheets, they look like this. Remember this stuff. Okay, this chapter, have we used the distance formula? Yep, so that'll be helpful when it comes to quiz time or test time. What about slope formula? Kind of, right? Because we've usually counted it out on the graph. Technically, we've used it. Over here, what about Pythagorean theorem? What kind of shapes have we used Pythagorean theorem on? Do you remember? Kite. Right triangles, of course. But do you agree that there's right triangles inside the kite? Okay, so you can use that. That comes up on today's assignment. Right here, see how they're teeny tiny? Here are all of your areas. So don't stress yourself out trying to memorize these because you'll get to use this on the test and on the CRT. But you do need to know how to use them. Not just here they are. So right here we've got square the sides, rectangle, A equals BH. What do you think the capital A stands for? B? H. Yeah, so that's the kind of stuff you want to walk yourself through. Okay, jump down to rhombus. Rhombus, the area is half D1, D2, and guess what the D stand for? It's diagonals. Good work. So you've got to know the whole diagonal. Now, there's actually one missing on here, and I don't know why they don't put it on there. Can you look at those shapes and then think of the shapes that we've talked about, the polygons? What are we missing, Ellie? We're missing the kite. It's never on there, and I don't know why. However, the only thing I can help you with is it's the exact same formula as the rhombus. So if you want to write kite and rhombus right here, they both use the same formula. A equals half times D1 times D2. The D stands for the diagonal. Good luck. I don't know why that's not on the reference sheet. A little bit frustrating. Okay, decide you can use them during your assignment. Let's go back to our notes. Okay, page 138, right? First part, I hope these make sense. Squares, we've been finding areas of squares for a long time. All you have to do is square the sides. Side squared, I literally was teaching this to my 7th graders today. Side squared, does that mean side times 2? No, side times side. So maybe write that in your notes just as a friendly reminder to yourself. Side times side. Okay, this one is saying if two polygons are congruent, they have the same shape, then they'd have to have the same area. I hope that makes sense too. It's the same thing, they have the same area. And then last one, you can always add up areas. So every once in a while on the CRT, you'll see shapes that's like a triangle, and then below it is like a parallelogram. So I have students stress out like, what the hell, we didn't learn triangle and parallelogram formula. No such thing, just add them together. Find the area of this one, and then add it to the area of this one. Add them together, that's the area of the whole thing. That's what that one's saying. Nod your heads, does that make sense? Okay, we kind of get into that today. Here come the formulas. A rectangle, do you have this one memorized? What is it? Perfect, base times height. A equals BH. Okay. Area of a parallelogram, does anybody have this one memorized, or are you looking at your reference sheet? It's the same thing. Why? Area equals BH. Okay, so if any of you had a math teacher that showed you why this is true? 10 of you, do you know why it's the same thing?
You could take like the triangle on the left and slide it over to the right.
Okay, he said you can take this triangle on the left and slide it over to the right. So it's like I gave you this parallelogram, I give you scissors, you can cut out that triangle, and then I give you tape, and you get to tape it right back here. Here's your piece of tape. Alright, so now here's your final shape, this green one. Did you just make a rectangle? Yeah. So that's why it's the same formula. Good one, Tyler. So same formulas. Now the tricky thing about this one, I don't know if I'll teach it to my 7th graders this year, but in years past I've taught them area of parallelogram. They kind of have a hard time deciding which one is the base and which one is the height. If you have the same problem, just think of it as which two things make a T. It might be upside down, it might be sideways. As long as it makes a T, one of them is the base, one of them is the height. Keep that trick in mind. Okay, next. Triangle. Do you have this one memorized? So you use this one? Anybody? Yes, base times height divided by 2. I'm going to write it like it's written on your reference sheet. They do half base height. That's just 1/2 times the base times the height. Why is it half? It's half of a rectangle or half of a parallelogram. Kelly, comment?
Because if you take the base and the height times it, you make a rectangle, and then half of that is just a triangle.
Perfect. Perfect, exactly. You can cut those into 2 equal triangles. It's half of the same formula. Okay, next one. Okay, this one, I was making a copy of the notes, and I was like, oh, dang it. I am guilty of not reading directions. So look at what it asks you to find, and then trace it on your picture. Because I thought this was one of those add the 2 areas together. But all they're asking for is A, B, C, D. That's it. Do we need this part? Maybe it's useful somewhere else. First off, that highlighted part in purple, what kind of shape is it? Okay, so let's use our parallelogram formula. If it's parallelogram, it's just BH. Alright, shout it out. What's the B then? It totally is 20. So base, we can use 20. What's the height then? 9. Makes a T if you kept going. So let's do area equals 20 times 9. What is it, guys? 180. And then since it's area, we always put the units squared. We don't have inches or miles or feet or whatever. So I would just put units squared. Good enough for me. Okay, let's keep rolling. What's next? Okay, this one, we're going to use the triangle formula, put in what we know, and solve for what we don't know. Don't be worried about these backwards problems. So first, start off with the area of your triangle. The formula is area equals half times base times height. Okay, and the problem, they only give us 2 things, and we have to find the missing thing. So right here, this 18, what is that standing for? The A, because it says the area has an area of 18, so instead of this A, I'm going to put 18. Alright, this 6 right there, what's the 6 standing for? The base. So we still have our half. We know the base is 6. We don't know the H. And we're just going to solve it backwards. We'll be fine. Okay, right here. Guys, what's half of 6? Done. Okay, so we got 18 equals 3 times some height. You can do this in your head or do the inverse operation. Guys, 3 times what will give you 18? There you go. You're done. The height was 6. And I don't think it has feet or inches, so let's just put units. I got that. Even though it's backwards, does that one make sense to you? Okay, same thing. It's just a formula. You're putting numbers in there. Okay, these ones, will you try them on your own first? Make sure you're positive what shape it is, and then use that shape's formula. Feel free to use your reference sheet or the notes before. What do you guys think? Yep. I'll totally take it. Pass the mic. Compliment for number 2. You can put them on the spot. We'll be fine.
Okay, so it's area equals 1/2 base times height. What's that? 134. Divided by 2, and you get 72.
Nicely done, Jaden. Compliment for number 2. Okay, so I got BH equals 60, and then B is 6, so that's 6. Nicely done. Guys, how many got the same thing? You okay with that backward one? Good work. Guys, I'm impressed. Good job. One thing I would suggest adding to each of these is what we did on the previous. So right here for Desi's, you could just put units squared, shortcut version. Units squared, perfect. Okay, I'll help you. This one, just put units. Okay, this one he put in his formula. Allie, thanks for asking. So 1/2 base height, you good with that? So you okay at the first step, 1/2, 16, 9. What he did is he did 16 times 9 first, got the 144, and then he cut it in half. That's not the only way you can do it because that's multiplication. Guys, can you do multiplication in any order? Yes. So right here, Allie, my brain sees it like this. I would have done half of 16. Let's have a 16. And I would have done 8 times 9 is, you'll get the same thing, just however you see it. Thanks for asking. Okay, next one. Okay, we're on to our special quadrilateral. Area of a trapezoid. Hopefully you've seen this before. This you have to be careful with because it involves order of operations. Area of a trapezoid, take half of your height and then times it by your bases. But you have to add your bases together first before you do any multiplication. Order of operations, parentheses comes first. Again, those B's just stand for bases. Now, check. Guys, do you think that it matters which one you use for B1 and B2? No. Absolutely not. Just make sure you're using the parallel sides and not the legs. Okay, here comes the kite and the rhombus. Remember, kite's the one that's missing on the reference sheet, right? The only help I can give you is that these are the same formula. So you take half of your diagonal 1 times it by your diagonal 2. They're all just multiplied together. Same thing with the rhombus. 1/2 times the diagonal 1 times diagonal 2. Same question with the trapezoid. Do you think it matters which diagonal you use for the first one or the second one? Absolutely not, because we're just multiplying. So it comes out the same in the end. Now I'm going to show you some stuff that I see when students try to use this one later. Oh, here we go. Area of a trapezoid. Let's write down our formula first. So the area for a trapezoid is half the height. Don't forget to add your bases together first. Okay, things I notice with this is when students highlight it, is this a base and this a base? No, those are called what? Those are legs. Don't use those ones. Those are legs. It's actually super convenient to be on a graph. So we're going to use this for our base and this for our base. Okay, check it. I'm going to keep saying this. Hopefully it hits home. Check that they're counting by ones first. We're good. So how long is this base right here? Totally. You can just count it out, right? 1, 2, 3, 4, 5, 6, 7, or just match it up with the y-axis. This is length 7. How long is this one? Totally. Length 4. So we've got our bases. So right here in parentheses, we can do 7 plus 4. Okay, the height. Anybody have a plan for finding the height when it's on this graph? No suggestions? Okay, ready? Height, just like I told you, I teach my 7th graders, it's got to make a T with one of the bases. So just maybe like right there, makes a T. Or if you look at it this way, makes a T that way. That's going to be the height of your trapezoid. Just count it out. How long is that? Is it 6? How many of you agree that it's 6? Okay, so let's use height 6. Don't forget to times it by a half. Okay, like I was showing Allie before, my brain kind of sees this differently. But I hope that you do this part first because it's in parentheses. Because what's 7 plus 4? Okay. So we'll have 1/2 times 6 times 11. In 7th grade, we call it mental math. Just do it in your head and be nice to yourself. So being nice to myself, I would rather take half of this than half of that. So what's half of 6? 3. So then you can just do 3 times 11, which is 33 square units. How many? I got that. That makes sense, yeah? Of course, you can use your calculators. You can type it all in. All right, let's look at our next example. Okay, what about this one? First off, look at your directions. What kind of shape is it? Rhombus. What about a rhombus and its sides? All sides are congruent? Okay. Now, formula for a rhombus, does anybody know what it is yet? Abigail, what is it? Perfect, perfect, perfect. All right, rhombus formula, half D1, D2. Now here's where I see slip-ups. Students are awesome at finding the formula, but be careful about applying it. D1. Doesn't matter which one you use. However, I see students use just this piece. Is that the whole diagonal? We gotta use the whole thing. So the whole diagonal is how long? Alright, that whole thing is 24. Another heads up, I see students do 12 times 12 and they get 144. Don't use 144, way too big. So add them together, that's our first piece. So we'll do 1/2 times 24 times the other diagonal. So this whole diagonal is how long? What's 16 plus 16? 32. Okay. Like I said before, I'm nice to myself, but this one I would probably bust out the calculator. Because I think, well, half of 24 is 12, but I don't know what 12 times 32 is. So I'm like, all right, half of 32 is 16, but I don't know what 16 times 24 is. So feel free to use your calculators. I'll show you on the board. You can use a decimal. So we've got 0.5 times them all, times 24, times 32. Not too bad. And we're finding areas, so that's square units. How many of you, I followed that one. Does that make sense? That's a new one that maybe you've never seen before. Has anybody seen that before? Have you seen any of that one? Okay. These three. Same as before. Will you try these on your own first, please? Before, what kind of shape is it? Trapezoid. So identify the shape and then use that formula. So trapezoid formula, area equals 1/2 times height. Don't forget to add the bases together. Okay, shout out the bases. What numbers are they? Perfect. So we'll have this 7, so times 7, times the 14 plus 6. Guys, what is 14 plus 6? Alright, so 1/2 times 7 times 20. Hey, mental math. I don't want to do half of 7 because that'll give me a decimal. So it's half of 20. And then what's 10 times 7? So our area is going to be 70 square units. If you don't like those little tricks, just use your calculator. Okay, one thing that does happen right here, is can I have your eyeballs up here? Do you have to take half of 7 and half of 20 and then multiply them? Nope, it's only in there once, and once it's multiplied, it's gone. So be careful with that. Okay, number 5. Number 5, what kind of shape is it? Okay, I really like this question because it's about notation. This 8 right here, is it saying this whole diagonal is 8? It doesn't look like each piece of the diagonal is 8. Okay, so be careful about that. So we're going to use 1/2 of the first diagonal times the second diagonal. So 1/2 times this piece is 8 and that piece is 8, so what's the whole thing? 16 times, alright, this one, put it all together, 11 and 11, 22, mental math, I don't know. It's either 8 times 22 or 11 times 16. Does somebody have this in the final yet? What'd you get, Annie?
I got
168
168.
square units. Does anybody agree with that? Do we get the same thing? Is she close at least? No, not close? Alright, let's do it on the calculator then. Alright, so 1/2 of 6. I'm just going to type it in as 8 times 22. 176. Yeah, I agree. You were somewhat close. How many of you got 176 square units? Feel better about that one? Okay, last one. What kind of shape is it? Kite. This is the one that you're going to have to remember. Sorry about that. Just remember it's the same formula as the rhombus. So the same formula as what we wrote in purple. Now look at this notation. Is this 40 for a piece of the diagonal or the whole thing? Okay, so that's the notation for the whole thing. So area is going to be 1/2 times 40 times this whole diagonal is 18. Okay, 20 times 18, I don't know what that is. However, I would probably combine these two, because what's half of 18? 9, so then we've got, what's 9 times 40? Can you do that one? There you go, 360 square units. Again, those are just little tricks. If you don't like the little tricks, just use your calculator. I'm okay with that. Question, Caitlin?
Well, I was just gonna say, instead of, you don't really have to write out 1/2 times 16 times 2 because it already tells you half of the diagonal, so you can just do like 8 times like 22.
Yeah, that would totally work. Thanks for pointing that out. The only thing that made me a little bit nervous while you're describing that, I was worried you're going to say 1/2 times 8 times 11. That'd be dangerous. But if you have one of them, that totally works. Thanks for pointing that out. Okay, you might want to keep your notebooks out so you have all the formulas. You've also got your reference sheets.